So let's see program for that problem, that is your traffic problem, you can say, because you have to find output from a traffic. So what will you do first? Okay, not visible. Okay, so first you have to import few modules. So these are your NumPy, Matplotlib and sklearn. Next step is to load your input data. So what will you do? Here your file is traffic-data.txt. So this file is containing the data set. Let's see. Okay, so this is your file. In this file it containing your day, then time, then your opponent team, then your yes or no, and then your number of vehicles passed by. So again it is repeating and like that. So this is your data set. Next you are loading data. So you are reading lines. So you will use open command for opening that file. Then you will use read lines, and then you will append your data in data variable, and then you are converting that data in array. So you are using NumPy module for that. Okay, this line was for loading your input data. Next is your converting string data to numerical data. Now your lines, your data set containing string variables, string data. So what will you do? You will convert them to the numerical data for further processing. So what will you do now? What will you have to use now? So you are using label encoder. Now what is label encoder? So label encoder is used to transform non-numerical labels to numerical labels. So this is the basic purpose of label encoder. So you are using that. So first what you are doing, you are enumerating your data variable, that is you are looping that data and you are getting item. Then what will you do? You are saving your data in X encoded variable. So you are using label encoder here, this label encoder, pre-processing.label encoder, and then this is your X encoded variable containing your data. Next you are using here fit transform function. Now what is that function? So the fit part applies to the feature extractor itself. So it determines what features it will base future transformations on. And next is your transform part. So transform part is what takes the data and spits some transform data back at you. So what is here it is doing? It is doing fit label encoder and return encoded labels. So this is your functioning of fit transform. Next again you have to split data into training and testing data set. So you are using train test split function of cross validation module. Then what you have to use? You have to use extremely random forest regressor. So what will you use? Extra trees regressor, and then you will pass parameters. So this is your n estimators, max depth, that is your height of the tree, this is your number of trees in that forest, and random state, that is your random data generator. Next you have to compute your regressor performance. So you are evaluating mean absolute error. So what is that? The mean absolute error is a measure of the quality of an estimator, that you know. Okay, so this is your regressor performance. Next is your testing encoding on a single data instance. So you are taking an example, you are taking test data point, that is your Friday, 10:20, Atlanta, and no. So you are taking this data point, and then you are taking your test data point encoded. So what will you do? You will enumerate your this data point. You are getting one item once. So first you are getting Friday, then this, then this, then this. So if your item is in the digit form, then you are directly taking it in this array test data point encoded, and if it is not in digit form, then you will have to apply transform function of label encoder, and then you are saving it in your test data point encoded. So this is your completely for loop. Next you are converting your test data point encoded in array form using NumPy module. Then you are predicting output for the test data point. So you are using predict function, and you are passing that test data point encoded in that function, and you're using regressor, that regressor is your extremely random forest regressor. So this is your predicted traffic. Okay, so let's run this program. So what you are getting mean absolute error as 7.42 and predicted traffic is your 26. Now what is that 26? That 26 is representing that vehicles are passing through that area and that time is your 26. So if you are seeing this file, then in this file at that date and that time there will be either number 26 or a number closer to that 26. So it is so that's why its name is, it is predicting output, not exactly, but it will show you the predicted output. So you can search in that. Now if you want to search, then see what is that. This is your Friday 10:20 Atlanta. So you can search here Friday, and then you can search 10:20. Next you can search Atlanta. So this is, let's see this is your 28. So this 26 number is closer to this number, so it is your predicted output. Okay, so in this way this will work. So what we have used here, label encoder for that. So this was your predicting traffic using that extremely random forest regressor. So that's it.